Hi there, Year 12s. I thought I'd do some examples from the textbook just to guide you if you're having some problems, especially when we get to the last few questions. So I'm just going to start off with a simple skill that you were meant to take out from my lesson video. So from the lesson video, you learned how to convert fractions and decimals to percentages, and then percentages back to fractional decimals. So here, when we're filling out this table in question 2 of exercise 3.2, you can see percentages, 64%. Percent in itself means out of 100. So if you were to write the fraction, it's just 64 out of 100. Now, from here, you can type it on your calculator and it can simplify it for you. If you can also do it, you can try to find a common factor, meaning what number fits in a 64 and 100. One of the first things I noticed is that they're both even numbers. So one of the easiest ways, you can keep halving until it gets really small. So for example, if I divide 64 by 2 and I divide 100 by 2, then half of 64 is now 32 and this is now 50. That's comparatively smaller. And they're both even numbers again. So again, I can divide by 2 again. And that gives you what? 16 over 25 is looking a lot better. And then maybe 16 out of 25. Are there any other numbers that I can fit in? And I don't think so. I think that's as small as you can get. So you can write 16 on 25 like that. So you can see how I've done it. I just simply find common factors. When they're even, the easiest factor is 2. Then how do you convert it to a decimal? Well, in itself, 64% means 64 of 100, right? But this symbol here, over 100, actually means divide. So the over or the fraction actually means divide, and you're saying divide by 100. So on your calculator, you can actually just type 64 and then divide it by 100, and you get the decimal, which is 0.64. Okay, so here we go. That's 0.64. Okay, so that was to convert from percentages to fractions or decimals. So I just literally read the percent symbol. Whereas in the reverse, if I want to convert decimals into a percentage, then we do the opposite. Instead of dividing by 100, we're now going to multiply by 100. Okay, so in this case, on your calculator, whoops, not that one. That was 0.75 times 100, and that gives you 75. So that tells us it's 75%. Okay, and why do we times 100? Because remember, per means every, cent means 100, so you need every 100. So if you have 100 of them, that's what percent actually is working out. Out of 100, what are you getting? That's why you're going to times by 100. Okay, and then same thing if you want to convert it into a fraction. Well, 75% actually just means 75 out of 100, and you can do the same thing again. Find a common factor. And then bring it down. For me, I know, yes, they're in 5s and you can divide it by 5s, but actually I know 25s fit nicely in both. So 25 fits into 75 3 times, and then 25 fits into 100 4 times, which is why people know 75% is the same thing as 3/4. Okay, so that's question 2 if you're working through that. And same thing with the fractions if you're confused how that works. Again, to convert fraction percentages times by 100 because you need 100 of them. Yeah, and it just means on your calculator you're typing 3 divide 8 times 100. Okay, and you get your percentage. So on my calculator, here we go, 3 divide 8 times 100. And there you go, 37.5%. Again, you can then fill out the decimal by dividing by 100. Hopefully you get the pattern there. You can probably do the rest now. So using that skill there, you should be able to do question 3, question 4, question 5, or whatever we've already selected for you. I'm going to find one that has a bit of a worded question. Oh, is that it? Okay, so it's only up to this bit. Let's try. Let's do 12. All right, let's just do 12. All right, question 12. Table shows the percentage of households with 0 to 5 children. So we've got 0 children, 1 child, 2 children, 3 children, 4 children, 5 children. Okay, so there's a number of kids. 56% have no kids, 16% have 1, 19% have 2, 6% have 3, and then so forth. Right? So I'm just reading the table. Now, A, the percentage of households that have 6 or more children. So 6 or more, well, 6 or more is in this direction. So technically it should be 0, but let's double check. How do you know? Well, this entire table should add up to 100%. So let's double check it. 56 plus 16. I'm just going to do it on a calculator. So 56 plus 16 plus, what's the other one? My computer's freezing. 19621. Okay. So plus 19 plus 6 plus 2 plus 1. Oh, that was a bit of a trick there. So if you add all the percentages, all of this actually only adds up to 85%. So there was a bit of a trick there. So that means 6 or more, anyone who has 6 or more, there's the leftover percentage of the population. So remember, it has to all add up to 100% to talk about the entire population, right? So because it only adds up to 85, that must mean there's 15% that is 6 or more, okay? So naturally, I was thinking 0, but good thing I checked that 56 plus 16 plus 19. Wait, did I type it right though? Let me just double check again. Oh, no, I didn't type it right. Maybe that's why it was a mistake. Okay, let's do it again. So 56 plus 16 plus 19 plus 6 plus 2 plus 1. Ah, no, sorry. False call. It was 0. No, they do all add up to 100%. Okay, good thing I double checked. You see, the thing about mathematics is that it's all about critical thinking. Now, the reason why I double checked again is because I noticed the question said 0 to 5 children. So technically, there should be 6 or more. So that's why I wanted to double check once more. But there we go. So now I know, yes, the 0%, based on this table or this survey anyway, there's 0% that would actually have 6 or more children. The percentage of households that have fewer than 2 children, so less than 2 is 0 and 1. So that gives me a total of 56 plus 16. And what is that? That's 66 plus 6, 72. All right, 72% have fewer than 2 children. The fraction of households that have no children. Okay, so this is where the skill comes in. They're asking you to convert now percentages to a fraction. So no children, I have 56%, right? So C, I have 56%, but they want a fraction of households. So I can't say it as 56%, I have to convert it to a fraction, which is 56 out of 100. And you can technically leave it there, but most of your answers should always be simplified, especially for exams. So 56%, already they're both even numbers, let's halve them. So half of 56, and then half of 100. Half of 100 is already 50. What's half of 56? That's what? 56, is it 28? Yes, it is 28. All right. And then, again, both even numbers, half it again. So that's 14 and 25. Can I half it again? No, I can't. But are they common factors? No. So that must be my answer, 14 out of 25 for C. And then finally, D, it says the fraction again. So they want a fraction of households that have 1, 2, or 3 children. So if you want 1, 2, or 3, it's 16, 19, 6. So if you add those two together, that gives you what? 25 plus 16. 25 plus 16 is 41, I think it is. Yeah, 41%. And 41 as a fraction is 41 out of 100. Okay, let me just double check that. 25 plus 16. All right? Yes, I was right. All right, and you can't simplify 41 over 100, or at least I think you can't. I can't think of a number that fits in both 41 and 100, and so that's your answer. So you can see that we utilize the skills of conversion up here, and then we interpreted a table. There's probably other questions that might be relevant to that idea. You might convert to a decimal, for example. Maybe I'll do question 10. I'll do question 10 and I'll finish it off there. Question 10, what's this? Air contains 21% oxygen, 0.9% argon, and 0.1% trace gases. And the remainder is nitrogen. Okay, so that's a hint that to find the remainder, you have to add all of these and then subtract from 100. Now, the nice thing is 0.9 plus 0.1, that's just going to give you 1% in total. So 1% plus 21 gives you a total of 22. So that means the remainder must be whatever's left over. So if there's 22% ready used, then the leftover for nitrogen must be, what, 78. And 78 plus 22 will add up to 100%. Okay? Again, if you weren't sure how to do that quickly, you could do 100 on your calculator, take away 22, and you should have got 78 from that. Okay? All right, so now I know nitrogen is 78%. Cool. It says calculate the percentage of nitrogen in the air. Oh, we happen to have just done that. So it was 100 takeaway, and we needed to figure out 21 plus 0.9% plus 0.1. Okay, so if you type that on your calculator there, so 100 minus brackets 21 plus 0.9 plus 0.1, that should give you the remainder, and that should give you 78. Okay. What else is there? Calculate how many liters of oxygen are present in 100 liters of air. Now, if there's 100 liters of air, but we already know that 21% is oxygen, okay? Because it says liters of oxygen. So air contains 21% oxygen. So you're really trying to work out of 100 liters, 21% of 100 liters is oxygen. What's nice about this is that it's already out of 100. Okay, and this is saying, well, for every 100, 21 is oxygen. So that means out of 100 liters, 21 liters must be oxygen. There was no calculations you actually had to do. Okay, but if you wanted to, for those who want to go a bit ahead, you can actually work this out by writing 21% as 21 over 100. In mathematics, of actually means times, and then 100, you just write 100. So if you type this on your calculator, write 21, divide 100, and then times 100, you'll be calculating 21 divide 100 here, and then times 100. It should give you 21. And that's how you know it's 21 liters is oxygen. Okay? And the last one, C, calculate how many liters of oxygen are present in 250 liters of air. So now it's the same concept again. We know 21% is oxygen, but this time it's 250 liters. Okay, and again, this one's a bit of a different skill, which is interesting because, I mean, you can think of it in many different ways. You can think of 250 liters is 2.5 times 100. Okay, so you start off with 100, and this is 2.5 more. So technically, you just needed times 21 by 2.5, and you get your answer. But just in case you didn't know that or didn't pick up on that, then you can still do what I just taught you before. 21% is 21 over 100, which means 21 divided 100. Of means times, and you got 250. So on your calculator, you're typing 21 divide 100, and then times 250. And that should give you the answer. So here, if I do it on my calculator, 21 divided by 100 times by 250, okay, that gives me 52.5. Yeah. So that means 52.5 liters is oxygen in a 250 liter. Was it liters of air? Yeah. Alternatively, like I said before, you could have just done 21 times 2.5. So had we just done it here, 21 times 2.5, and you would have got the same answer. Okay. But regardless, all good. There we go. So I just did, probably question 10 was one of the trickier ones. Maybe that was useful for you guys. But there you go. So I'm just giving you a sense of what you needed to know. This is the general skill that you need to know. And then as you get towards the end, those are the kind of exam questions that you want to get familiar with. So you got to be able to be flexible with using your skills in conversion and also then interpreting what the table's telling you, what are some details you're missing to fill out the gaps. Okay? All right, team, I'm going to stop the video there, and that's it.